Good morning, students. Within 1 minute, we will start. Yes, we will start. Yesterday, we completed the chapter number 16, that is the green chemistry and nanochemistry, which is having weightage 3 marks with option. And another organic chemistry chapter, which is a very small chapter, that is amines, we started. And in this chapter amines, we completed the nomenclature system, what is meant by primary amine classification, then different methods of preparation of amines, then yes, these methods of preparation yesterday I completed. Just I want to revise within 1 minute because this is a very important for board exam. This ammonolysis of alkyl halides. Ammonolysis means it is nothing but the reaction of ammonia with alkyl halide. Excess of ammonia we have to use here. If excess of ammonia is not used, we can get these 4 different products. Please remember this. So ammonolysis means breaking of this Rx bond, that is the CX bond, by using ammonia, and this may be asked for 1 mark. So this reaction is completed yesterday, and remember this thing: if the ammonia is not used in excess, we will get the product secondary amine, tertiary amine, and quaternary ammonium salts. Then second method we discussed, this is the reduction of nitro compounds, means NO2 group, how it is converted into NH2 by reduction with SnSCl. Then we can use the FeSCl also. You can use H2 palladium, H2 platinum, ranitidine or lithium aluminum hydride, or NaBH4. We can use here any reducing agent. And opposite to this, we can convert this RNH2 group, that is ammonia, RNH2 primary amine, into nitro compound by using oxidation. We can use here different oxidizing agents. Though it is not shown in this slide, but we have to remember NO2 group is converted into NH2 by reduction, and NH2 group is converted into NO2 by oxidation. And you know the different oxidizing agents, KMNO4, then copper, then CrO3. So you can use different oxidizing agents. So this is a Mendes reduction. Yesterday also we discussed. This is a conversion of cyanides and nitriles into amines. This is a step-up reaction in which the length of carbon is increased. So this reaction is called a step-up reaction in which the length of carbon is increased. I explained this example also. Then reduction of amides. Reduction of amides, this CO carbonyl is converted into CH2. Also, these such type of reactions we explained in the chapter aldehyde ketones and carboxylic acids by using lithium aluminum hydride, by using Olp-Kirchner reagent, by using Clemenson's reduction. So this is a revision for yesterday's lecture, and this Gabriel phthalimide synthesis also I explained. This is having three-step reaction. In the first step, this phthalimide is converted into the salt. This is the salt. In the second step, this salt reacts with alkyl halide to form L-alkyl phthalimide, and this N-alkyl phthalimide, after alkaline hydrolysis, we get the primary amine. This is a major product, remember, but the student assumes this is a major product. This sodium phthalate is not major product. This is a primary amine is major product, and the main disadvantage of this method was aromatic amines cannot be prepared by this Gabriel phthalimide synthesis, because in this step, instead of this alkyl halide, if the aryl halides are used, here, see, aryl halides do not undergo nucleophilic substitution reactions, but the alkyl halides can easily undergo nucleophilic substitution reactions. So the organic chemistry, don't feel this organic chemistry is very difficult. Make a practice at your home. Many students yesterday called me from the different areas, different cities, because all of these got the reduced copy of the textbook. I suggested one thing. If you practice organic chemistry daily, at least 30 minutes you have to give. Then it will be very easy. Otherwise, if you make a delay in preparation, then it will be very difficult. So we are discussing this reaction, and this is very, very important reaction for board exam. I suggested we have to write this reaction for 10 times. Hofmann bromoamide degradation reaction. See, the name of the scientist is Hofmann, who discovered this reaction. Hofmann bromoamide. Say, Hofmann is the name of the scientist. Bromine is used in this reaction, and amides are used. That's why it is called as Hofmann bromoamide degradation reaction. So in this reaction, see, amide we have to convert into amines, but one carbon is less. See, this CO group is degraded. A degradation means we have to step down reaction. Degradation means it is a step down reaction. This CO, we have to remove it, and the length of the carbon chain is decreases. That's why it is called as Hofmann bromoamide degradation reaction. One example is shown here. This is acetamide plus bromine plus 4 molecules of KOH, or you can use here 4 molecules of NaOH also, and we get here CH3 and H2. See, this CO is removed here. CO means carbonyl group is degraded, and all these are the byproducts. Twice KBr plus K2, CO3 plus twice H2. All these are the byproducts. This is the main product. So this reaction many times asks for the board exam. This is also called as Hofmann rearrangement reaction. This is a homework I have given for your practice. So today I will send you the notes of this chapter, because I want to make some changes. That's why I didn't send you. So now the notes are already prepared. The answers are also given. If you didn't know the answers of these questions are not from your textbook. I have taken from the different textbooks. So the questions are also given here. Answers are also given. Now we will start the physical properties of amines. This is used for CET exam, NATA exam, then JE exam, and NEET exam. For the board exam, no any question is asked on it still now. The first property is intermolecular forces. Now you are very familiar about this word. Intermolecular forces are the forces between the two molecules. That's why it is called as intermolecular forces. Now we will consider this is a primary amine. See, in case of primary amine, one nitrogen is there, and two hydrogens are there in the primary amine, and one hydrogen is there in the secondary amine. In case of tertiary amine, there is no any hydrogen atom is attached to this nitrogen. So what is happening due to this nitrogens and hydrogens here? The electronegativity of this nitrogen is very high and the electronegativity of this hydrogen is very less. Say it is that's why due to this electronegativity factor of nitrogen and hydrogen, this bond becomes polar. Nitrogen and hydrogen bonds in case of amines, it is polar because the electronegativity factor is there. Nitrogen is more electronegative. It pulls the electron towards itself. So it will acquire the delta minus charge here and the hydrogen will acquire the delta positive charge. And these are the very common things, electronegativity. In 11th standard, we learn about this electronegativity, means the ability of the atom to attract the shared pair of electron towards itself. This property is called as electronegativity. So due to this electronegativity difference of this nitrogen and hydrogen, primary amines having the more intermolecular hydrogen bonding. Because in case of primary amines, there are two hydrogens attached to the nitrogen. In case of secondary amines, there is only one hydrogen is attached. So its intermolecular forces will be weak. And in case of tertiary amines, now I want to discuss about the tertiary amines. So what will happen in case of tertiary amines? So these hydrogen bonds are shown here. See, this NH bond is polar. This is one primary amine. This is secondary primary amine. This is third primary amine. This is fourth. So in case of many primary amines are there. See, this hydrogen bonding is present between nitrogen and hydrogen. So these hydrogen bonds are very strong in case of primary amines because there are two hydrogens. So these two hydrogens can form two hydrogen bonds, but in case of secondary amines, they will form only one hydrogen bond. And in case of tertiary amines, they do not having any hydrogen, so they will not form the hydrogen bonding. But there is also the polarity between this nitrogen and carbon, because the electronegativity difference is there, nitrogen and carbon. So the intermolecular forces present in case of tertiary amines are the dipole-dipole attractive forces. Remember, in case of tertiary amines, the forces present are dipole-dipole attractive forces, because in case of tertiary amines, the hydrogen bonding is absent because there is no any hydrogen. So if the question is asked for board exam, in which amines the intermolecular forces are stronger, so your answer should be, in case of primary amine, these are the intermolecular forces are strongest, and in case of tertiary amine, it is weakest because of absence of hydrogen in case of tertiary amines. Then the second property is boiling point. This boiling point depends upon the say again the intermolecular forces. As you just we discuss about the intermolecular forces, in case of primary amines it is stronger. So primary amines having the, see this table given here, serial number 1, serial number 2 and serial number 3. First one is primary amine, second one is secondary amine, and third one is tertiary amine. And if you see, the molar mass is exactly same, but see the difference in case of boiling points here. We can see in case of primary amine, see the boiling point is 350.8 Kelvin. In case of secondary amine, see the boiling point is 329.3 Kelvin. And in case of tertiary amine, see the boiling point is 310.5. Means, see the boiling point of primary amines is very large because the intermolecular hydrogen bonding is very strong because of the two hydrogens. These two hydrogens are responsible for increasing, and the very amount of energy is required to break this bond, and very less amount of energy is required to break the bond between nitrogen and carbon. So tertiary amines having the very less boiling points, and primary amines having the very high boiling point. This is the reason behind this. Then another some properties are there. The lower aliphatic amines are gaseous, and which is having fishy odor. The middle members are liquids and higher members are solid under ordinary temperature and pressure. Aniline, this is a very famous aromatic amine which is having NH2 group is attached to benzene, and other aryl amines are usually colorless. Both are colorless, but if you found in our laboratory, aniline is also there. When the college will start, I will show the aniline is red colored, because this red color is due to the oxidation of aniline, they easily gets oxidized. That's why they occurs in red color. Actually, the aniline and other aryl amines are colorless. But if you see the bottle of aniline, we will find it is red colored because they suddenly get oxidized when the bottle is opened. Oxidation takes place and it becomes red color. Then the solubility. Now, again, I am going to discuss the basic things about the solubility. Solubility depends upon the polarity. Polar solvents dissolved in, polar molecules dissolved in polar solvents and non-polar molecules dissolved in non-polar molecules. So, I will explain. You know, this bond is polar. This nitrogen hydrogen bond is polar, so these are easily dissolved in water due to the ability to form hydrogen bond with water molecule. See, this is a water molecule and this is a primary amine. We can see here the hydrogen bond is formed, the bond between oxygen and hydrogen. So the lower aliphatic amines are soluble in water. Remember, lower, I am talking about the lower only. The lower aliphatic amines are soluble in water. But what is happening if the number of alkyl groups are increases? This solubility of amines will be decreases because as the hydrocarbon part increases, this as hydrocarbon part is hydrophobic, this hydrophobic alkyl group, it is water hating. So if the number of alkyl groups are increases, the solubility decreases. Remember, this factor also I discuss in the chapter alcohols, phenols and ethers also. Solubility decreases when the number of R groups increases because these alkyl groups are hydrophobic. Hydrophobic means these are the water hating, they hates water. That's why the solubility decreases. And in case of aromatic amines and higher aliphatic amines are insoluble because of this property. So solubility, I think you understand the factor solubility. Then I'm coming to the next one. These questions are very important for the CET exam. Remember, for the CET exam, then for the NEET exam, for the JEE exam, for the competitive exam, this part is very important. But related to the board exam, I think this is not important because many questions are asked for this depend upon the solubility and which is more soluble, which is less soluble, which is having higher boiling point. If you understand the concepts, then you can write the answers of these questions. So for the competitive exam, those students who want to give the competitive exams like CET and different exams, so please listen carefully. This is a comparative solubilities of amines, alcohols and alkanes. See, all these three are different functional groups. Amines are a different functional group, alcohols having the OH group, and the alkanes having the carbon single bond carbon. So there is again the solubility means again there is a factor of polarity. So NH bonds in amines are less polar than OH bonds in alcohol. Now OH bond is more polar because the electronegativity of oxygen is more and the electronegativity of nitrogen is less than the oxygen. So OH bond is more polar than NH bond. So what is happening due to this? Alcohols are more soluble in water. Then amines and then alkanes are not soluble because alkanes do not form any type of hydrogen bond with water. So this is the simple reason alcohols are more soluble, then amines are soluble, and then alkanes are soluble. Now, if you consider about the boiling points of alkanes, amines, and alcohols and carboxylic acids, now I am considering not the solubility. Now I am coming to the boiling points. Now this boiling point factor depends upon the intermolecular forces. Now the intermolecular forces are very strong in carboxylic acids, remember. Then in case of alcohols, then amines, and then in case of alkanes, there is no, these forces are very, very weak. So see the boiling point difference between the alcohols, carboxylic acid. See here, one example is given. This is the carboxylic acid. All these having the same, near about the same molar mass. But if you see the boiling point difference is very large. In case of carboxylic acids, see the boiling point is 414.4. It is very high because the intermolecular forces are very strong in case of carboxylic acids, then weak in alcohols, and then again weak in amines, and there are absent of intermolecular forces in case of alkanes. See the boiling point differences, clearly we can see the differences, and the main factor is intermolecular forces between these. So I'm not wasting my time in this, because already you know the polarity and solubility. So basicity of amines, a very important question is asked many times for the board exam. Remember the question, why amines are basic in nature, or explain the basic nature of amines. This basic nature of amines is due to the nitrogen having the lone pair of electrons. Remember, nitrogen having the lone pair of electrons, and according to the two theories are there. One is Lewis theory and another theory is Laurie-Bronsted theory. Here I will explain one by one. So what is Lewis theory? Lewis is the name of the scientist, and according to this Lewis theory, the amines are bases. Lewis theory I will explain first. What is this Lewis theory? Lewis is the name of the scientist and who had given the definitions of acids and bases. So I will explain the definition of base. According to this scientist Lewis, the substances which donates its lone pair to the another atoms, it is called as base. So amines is also having the lone pair of electrons here. In case of primary amine, in case of secondary amine, in case of tertiary amine, we can find the lone pair of electron is there. So this lone pair is given. So these are electron pair donors. According to the Lewis theory, these are bases. According to the Lewis theory, these are bases. All the amines are bases because this lone pair is shared with another electron deficient. See, one example is given here. This is a trimethyl amine. This is Me means this is methyl group. This is a trimethylamine plus BF3. It is electron deficient. So this nitrogen having this lone pair. We can see clearly here, though two electrons are there. It is called as a lone pair. It can be given. So this is salt is formed. This salt is formed. So according to the Lewis theory, amines are also base. Now I am coming to the another theory. This is Laurie-Bronsted, another scientist. Laurie-Bronsted also explained what is meant by acid and what is meant by base. So the basic nature of amines is explained by using this equilibrium. So this is amine. This is amine plus water. We get here conjugate acid. This is the conjugate acid of amines. So what is meant by conjugate acid? This hydrogen is accepted. So according to the Laurie-Bronsted theory, what is meant by base? The substances which accepts the proton from the acid, it is called as base. So this is amine. This is a general amine. It is shown. It may be primary amine, it may be secondary amine, it may be tertiary amine, and this is acid. So proton is accepted from this H2O, and we get the conjugate acid. So according to these two theories, Lewis theory and Laurie-Bronsted theory, amines are basic in nature. So if the question is asked for board exam, why amines are basic in nature, we can write any one answer of this. Lewis theory, we can write this according to the Lewis theory, it is best, or according to the Laurie-Bronsted theory, it is best, or you can write both the answers also. So this basicity, like acidity, for the strong base, Kb value is larger and pKb value is very small. We discuss about the acidity in carboxylic acid chapter. If the pKa value is small, the acid will be strong, and Ka value is large, the acid is strong. So opposite to this Ka value and pKa value, there are pKb values. pKb values, these are related to the bases. So when the pKb value is very small, we can see in this chart, see the value is 3.0 here. So these are the secondary amines. Secondary amines are very strong bases. See, we can see these values. Secondary amines are very strong bases. See the ammonia here. Ammonia having the value 4.75. So ammonia is weak base. Then primary amines are also weak bases. Then the primary amine basicity increases. See, the basicity increases because the pK value is very low, and in case of secondary amines are the strongest base. So ammonia is a very weak base according to this table. According to this table, I am discussing the basicity. Basicity depends upon the pKb values here. Ammonia having the very large, but in case of aromatic amines are very least basic. I will discuss the reasons. See the values also, the values of pKb, values of aromatic amines are very large. So aromatic amines are very weak bases. We will discuss the reasons also why this is happening, and according to the equilibrium, what is happening. So basic strength of, in case of aliphatic amines, we will discuss first this ammonia, primary amines and secondary amines. Again, these questions are asked for CET, very important, remember. See, according to the table, we can clearly, it is seen here, the basic strength. See the R2NH. This R2NH is a secondary amine, NH3 is ammonia, this is primary amine, and R3N is a secondary amine. So according to this order of basic strength, it is clearly seen that R2NH means secondary amines are very strong bases. And this is according to this table. And why this is happening, we will discuss the reasons here. There are also the inductive effects which affects on the basicity, and you know about the inductive effect. What is mean by inductive effect? It is electron donating effect. Greater the stabilization, say, one important factor I want to share with you. This basicity depend upon the stabilization of the base. So greater the stability of the protonated amine means this ammonia accepts the hydrogen. It is called as protonated amine. Say this is NH4 plus, means ammonia accepts the proton. This is a primary amine accepts the protons. In this secondary amine accepts the proton, and tertiary amines accept the protons. So all these are protonated amines in which greater the stability of the conjugated acid, then greater will be the basicity of amine. So you know, in case of primary amines, there is no any inductive effect because there is no any R group is attached. In case of primary amine, only one R group is attached here. Only one R group is attached, and in case of secondary amine, two R groups are attached here, and in case of tertiary amines, three R groups are attached. So if this we consider this factor of inductive effect, this tertiary amine should be more basic because these three alkyl groups stabilize this nitrogen more. Ammonia is very least basic because there is no any R group. In case of this primary amine, there is only one R group. In secondary amine, there are two R groups which will donate the electron pair to this. So according to this inductive effect, the tertiary amine should be very strong base because of the three R groups. But this is not happening. We can see this table also. The secondary amines are very strong. Secondary amines are very strong bases because the values, see the values here. But why this difference is occurring? So there should be some another influencing factor should be there. So that factor is this influence of solvation. So due to this solvation property, the secondary amines are very strong base. Now I will explain what is meant by this solvation. Solvation means when the protonated amines are dissolved in water. See, on this stabilization of conjugate acids of the aliphatic amines, it is shown here. See, all these are the protonated amines. This is NH4. This is protonated primary amine, this is protonated secondary amine, and this is protonated tertiary amine. See clearly here 1, 2, 4 water molecules are there. So there are 4 hydrogen bonds are there. 1, 2, 3, 4. There are 3 hydrogen bonds are there. There are 2 hydrogen bonds are there, and there is only 1 hydrogen bond is present. So by this solvation, it is clearly we can clearly see here. The solvent water stabilizes conjugate acid by hydrogen bonding. In case of this NH4, there are 4 hydrogen bonds, and in case of primary amines, there are 3 hydrogen bonds. There are 2 hydrogen bonds, and there is only 1 hydrogen bonds in case of the tertiary amine. So There is a combined effect of plus I and solvation. We can see clearly as the number of alkyl groups increases here. See, plus I effect. Plus I effect is more strong in case of tertiary amines because of the three alkyl groups are there, and the solvation increases here in case of NH4. Clearly see here, solvation factor is more in case of primary amines because of there are four hydrogen bonds, and solvation is very poor in case of tertiary amine because there is only one hydrogen bond. So the combined effect, if you consider the combined effect of plus I and this solvation, we can clearly see here, this is a secondary amines are there. So the net result of this solvation and plus I effect, it is found that the tertiary amines are weaker bases than the secondary amine because of the stabilization of the conjugate acid in case of tertiary amines. By solvation is very poor, and by solvation of this conjugate stabilization of conjugate acid in case of NH4 is very strong, but this effect is very less. Which effect? Plus I effect is very less in case of ammonia, but the solvation effect is very strong. But if you consider the secondary amines, both the effects are very strong here. Plus I effect is also strong and the solvation effect is very strong. That's why the secondary amines are very strong bases. Remember, these questions are very important for the CET. Again and again I am discussing this factor. If you didn't understand this one, again and again read this part, because for the advanced exam, JEE advanced also, these questions are asked many times, and each and every year the question will be asked on the basicity of amines. Remember, for the board exam this part is not so much important, for the competitive exams, again and again I'm discussing, because this basicity of amines is very important. Many students didn't understand why this is, the secondary amines are very strong base, because the two factors are responsible for this basicity. One is solvation and one is plus I effect. Remember, don't consider only the plus I effect. If you consider the plus I effect, the tertiary amine should be very strong because there are three R groups, but this is not happening. Clearly we can see this chart indicates, this chart given these values. So tertiary amines, see the tertiary amines values are much higher than the secondary amines because there is a two combined factors are there. So for the board exam, this is not important. No any examiner will ask, write the influence of solvation, write the influence of this plus I effect. This is for your understanding the concepts, why, what is mean by this plus I effect and how it plus I effect affects the basicity, what is the solvation. So remember, no any question will be asked for board exam on this to write the solvation effect or write the influence, but the question will be asked depend upon the basicity, why this is a strong base and why this is weak base, give reason. So for the give reason purpose this will be asked. So I think I explained in detail. Now I am coming about the basicity of aromatic amines also. Now we discussed the basicity of aliphatic amines. Now I will discuss the basicity of aromatic amines. And according to the chart, we can see clearly. Once again, I want to show this chart. According to this chart, see this is these are the values, pKb values of aromatic acids. We can see these values are very high. So which factor is responsible for these values? I will explain this factor. The main factor of the aliphatic amines and aromatic amines is benzene ring is attached here. See, benzene ring is attached in case of aromatic amines, and in case of aliphatic amines there is no any benzene ring. So what is the effect of this benzene ring? This lone pair of electrons, it is stabilized. See, this lone pair of electron of nitrogen, it is involved in this benzene ring. So in case of aliphatic amines, there is no aromatic system. So this lone pair is easily available for donation, which is a strong base. If this lone pair is easily given, then it is strong base. If this lone pair is not available for donation, then it is a weak base. Remember, this is a simple thing we have to remember. basicity and acidity. If the lone pair is easily available for donation, it will be the strong base. Then if the hydrogen is removed easily, it will be the strong acid. Remember, these things are very important to understand what is a strong base and strong acid. In case of amines, this lone pair, in case of aromatic amine, this lone pair is not easily available now in case of such type of amines, aromatic amines. This is involved in this it is given here, the lone pair of electrons of nitrogen is conjugated to the aromatic ring. Means this is involved. This is involved in resonance. That's why it is not available for protonation. Protonation means this is not available for donation. So if it becomes the hydrogen, the conjugate acid is anilium ion is formed. This is an anilium ion and this is aniline. So ammonia is strong base than anilium ion because there is no any lone pair is available. Because one question is asked for board exam. Which of the following is strong base, aniline or anilium ion? So in case of anilium ion, clearly see lone pair is not there. So it is a weak base and this is a strong base if we compare this. And if we do the comparison of aromatic amines, aniline and ammonia, if we compare the ammonia and aniline, so ammonia is a strong base, aniline is a very weak base because this lone pair is not available. So this is a stabilization, see how this lone pair is involved in resonance. So this is a, for your understanding I have given. So as this lone pair is involved in this resonance structures, this is not available for protonation. That's why the aniline is a very, very weaker base than the aliphatic amines. So for the give reason, it may be asked for exam, aniline, why the aniline is weaker bases than aliphatic amines. So your answer should be clear because this lone pair is not available. This lone pair is not available for donation. It is involved in resonance. Clearly we can see. Don't draw these structures. This is for your only understanding. For your understanding purpose, I have given this one. So this is again anilium ion is shown. This is a very weak base because same reason lone pair is not available. But we can increase the basicity of this aromatic amines by using these groups. See, the electron donating groups are attached. For example, OCH3, then CH3, NH2. These will increase the basic strength. Why? Because these are electron donating groups. These electron donating groups, if these attach to the aniline, what will they do? They will give their electrons to this one. This will give the electron to this nitrogen, and this lone pair will be easily available if these electron donating groups are attached. See. So these groups are very important. So these questions will be asked for CET if these groups are substituted anilines. This is called as substituted anilines. And this is electron withdrawing groups NO2, C6H5, SO3. Then this is carboxylic cyanide. This is halogen. When these are attached to the aniline, they decrease the basicity because they withdraws the electron again. So this ammonia lone pair is also involved and they NO2, C6H5, they will again withdraw the electrons and so this lone pair will be not available for the protonation. So this is a very important part I explained today because this is a very, very important for the CET exam. Basicity, which is a strong base and which is a weak base. So I will complete this reaction and we will stop here. Alkylation of amines. Alkylation of amines, just I explained the ammonolysis. This reaction is same as ammonolysis. I explained there. If the excess of ammonia is not used, we get here 4 different products. The same reaction is repeated here. That's why in bracket also I have given here, refer the ammonolysis of alkyl halides. Alkylation of amines, it is nothing but when this primary amine, it is react with alkyl halide. Here alkyl halide, it is used in excess. Alkyl halide heated with excess, then we get the mixture of the secondary amine because as this alkyl halide is in excess, it will react the secondary amine again, we will get the tertiary amine here. Again, it will react with alkyl halide and we get final product is quaternary ammonium salt. Why this is quaternary ammonium salt? Because there are 4 R groups. That's why it is called as quaternary ammonium. And why it is salt? Because nitrogen having the plus